Okay, bro, so the next part is, so now that we have the actual, like, basics around it, we're actually going to go for the actual rules of SciPi notation. So the first one is that the number in front of the decimal, so if you see here, where's my pen? Where's my pen? Okay, so as you see here, the number in front of this decimal must always be between 1 and 10. I'm sorry, my hands are so shaky. So that includes 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, 8.0, 9.0. So those are all acceptable. You will never ever put a decimal or number in front of the decimal that is not any of these numbers. And just important to note that 1.0 is not the same. This sign right here, this symbol, this means not equal. So 1.0 does not equal 10, and it's not the same thing as 10 with a decimal in front of it. So, and that applies with all numbers. I know it sounds really weird because like this is 10 and this is 10, but with a decimal. I mean, it's technically the same number, but when you're applying it in scientific notation, they are not the same thing. That's why the decimal is super, super important. You won't see 4 times 10 to the third power. You won't see that. You will always see 4.0. Okay? The second rule is, so your exponent, so if you remember over here, your exponent right here, it's always going to be the number of spaces you have moved. So we're going to take a look at this number. This is a number that they gave us. We're adding this decimal here because it wasn't there before. So we add the decimal, and it wants us to put this number in scientific notation. And we know that the number in front, sorry, there we go. So we know that the number in front of the decimal has to be between 1 and 10. So if we, obviously we're at this number right now is not a number between 1 and 10. It's way, way out there. So if you were to move this decimal one space to right here, it's still a bigger number than 10. So we're going to move it again. And then now we're going to cover that. Is that number still bigger than 10? It is. It's 48,000 something. So we're going to move it up one more time. And we're just going to keep moving it until we're within the 10 range. So this is 4,000. We're going to move it one more time. And now that's 483. So if we were to put the decimal right here, we would still be way off. So we're going to move it again. And you're going to be thinking, well, if the decimal is going to be, like if you put the decimal here, well, the 3 is less than 10. No. We always want the number in front of the decimal. So to this side of the decimal, in front of it. So we're still at 48. We're going to move it again one more time. And so if we put the decimal here, right behind this 4 is between 1 and 10. There's only one digit, and that is where we want to go. So we have moved this decimal all the way to here. So this decimal is bye-bye. We're going to get some white out. It's gone. Boom. And these blue little triangles I made are the amount of spaces we skipped. So we skipped 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we now know that we skipped 6 places. We moved the decimal 6 places, 6 digits. So when we write it, we have our whole number in front of it. So we have the 4. We now know the decimal goes right behind the 4. We have the 8 and the 3 because we can't get rid of this. These are important numbers, but we're trashing the rest of these zeros. Okay, and now we know that scientific notation always has to have the base 10 and the exponent. So now now we have our simplified number. We're going to add the base 10. So we always times base 10. And the amount of spaces that we moved again is 6. And we're gonna make a little superscript, a little 6, just like that at the top. And so now this is our answer. It's one whole answer. Another version. So in this one, give me 1 second. We're gonna make this, actually, yeah, we'll go with this. Sorry. All right, so we're gonna do this one next, this number. And we're gonna do the exact same thing. We're gonna move the decimal however many spaces that we need to. And notice that we have one more 0, but you're gonna notice that what we care about is the amount of places, not how many zeros there are. So again, we're gonna move this decimal, how many spaces? So if we cover that up, we moved up 1 space. Imagine that the decimal is right here. It's still bigger than 10. So we're gonna move it again, and we're gonna keep moving this decimal until we start hitting a range that we want. So if we were to put the decimal right here behind this 8, we would still be wrong because this 48 is greater than 10. So that means that we have to move 1 more space. And now the decimal is going to be behind the 4 because 4 is less than 10 and greater than 1. And we're going to count how many spaces we skipped. So we have 1, 2, oh, sorry, you can't see that. 1, 2, 3, 4, 5, 6. So again, 6 places. So our new number, my hands are so shaky. Okay, so our new number, it's not really new, it's the same number, but so it's gonna be 4. We're gonna keep that decimal place where we moved it, because remember we moved it all these places to right there. So that's our new place. We're gonna keep the 8, but we're going to we're gonna throw all these zeros away. They are now in the exponent, if that makes any sense. Basically, we're not truly trashing them, we're just rewriting this entire number in a new way. So these zeros aren't gone, but when it comes to writing it out, we're not caring about them. So we're gonna add our multiplication sign, we're gonna add our base 10, and remember that we moved 6 places. So we're gonna make another subscript or superscript, a little 6 right here, and that is our answer. So same amount of spaces, but different number. Notice that. And one more example. So I know I just told you that we don't care about zeros, and we don't, unless we have a number like this. And so now, now we're gonna do the same thing. We're going to put our decimal here, because we always want to put it at the end. And we're gonna move our spaces. We're gonna go 1, 2, 3, 4, 5, 6. So we are moving the decimal 6 places because none of these zeros hold any value. It's just a 4 there, so we know we just need to get to the 4. And that's between 1 and 10. Because anything before that is 40, 400, 400,000, etc. So we just want 4, just 4. And we're going to count how many spaces we did. So 1, 2, 3, 4, 5, 6. That's how many we skipped. So now our number is 4. But we can't move on just yet. We have to always have the decimal. And we're still not done because remember, over here, these are not the same thing. They are not all the same. So we have to add 1 0 just to show that we are in fact doing scientific notation. Okay, So, but the rest of these zeros, these 5 other zeros, we can trash them. However, that does not change the amount of places. It's just changing what numbers we care about in this number right here. So this whole number, this whole numerical value, we're only putting the 0 because there's nothing else to hold the decimal place. We need that decimal place, the decimal point and the decimal place after it. So now we're going to continue. We're going to make our little multiplication sign. We're going to add our base 10. And just because we kept 1 0 in the number doesn't change the amount of places we skipped. So we have 10 to the 6th place.